Hello, hi everyone, good afternoon. So today we are going to learn about laws of refraction. So till now we have learned all the different types of reflection which are there in your grade 10, and now we'll start with the refraction. Okay, so let's begin. This is about me. If anyone here is seeing me for the first time, there's me. You can say hi so that I'll know you're watching. Hi Pratik and Padmini. Your name is Vinay. Hi Vinay, good afternoon. Hello Ashu, good afternoon. Nice to see you again. Alright, so I hope the reflection topic was clear, and now let's learn about refraction. Okay, let's start. So there's a question. Light travels along a straight line path in vacuum. Is this true or false? We used to learn it, right? Light always travels in a straight line. Is it true or false? Yes, this is true. This statement is true. But is it always going to be true? If let's suppose it is not vacuum, if I change it to some other medium, let's suppose atmosphere, or if I change to water, right? Can this statement be true? The answer is no. Okay, first learn about this one. We know you have done this experiment, I think in grade 7th or 6th. So it shows that the light travels in a straight line. But there is one condition: as long as the medium is same. This is a transparent medium. Right now it is air or vacuum. If the transparent medium is air or vacuum, light travels in the straight line. But if you change the transparent medium, what happens? So that we are going to learn today. Hi Gummies in India, Naresh, Priya, good evening. Maths and Science, Sachi Kumari, good evening. Alright, now you must have seen, if you put a pencil in a beaker which has water, near the edge it appears that the pencil is broken. And if you take it out, you will find out that pencil is not broken. पेंसिल पूरी की पूरी है यहाँ पे, है ना, बट सिर्फ हमें दिखता ऐसा है कि यहाँ पे एट द एज पेंसिल ऐसे टूट गई है, इट इज ब्रोकन. सो व्हाई इज दैट? तो यहाँ पे क्या होता है, व्हेन द लाइट ट्रैवल्स फ्रॉम वन ट्रांसपेरेंट मीडियम टू अनदर. सो एयर एंड वाटर बोथ आर ट्रांसपेरेंट मीडियम्स. सो व्हेन द लाइट ट्रैवल्स फ्रॉम वन टू अनदर, व्हाट हैपेंस? There is a bending of light. You see here in this region the light bends. So whenever light travels from one medium to another medium, there is a bending of light, and this bending of light is called as refraction. Clear? Hi National Science Center, nice name. So understood what is the refraction of light? When the light travels from one transparent medium to another transparent medium, near the boundary or near the edge, it appears that the light rays bend, and this bending of light is called as refraction of light. Okay, so now let's understand some of the rules here. So this is our incident ray. Incident ray is coming from medium 1. Let's suppose this is medium 1, there is air, and it falls at the boundary at this point. There is our point of incidence. So you can draw a normal. This n prime is our normal. Until now it is similar to the reflection. But now what happens? This ray, it does not reflect. It goes into the second medium. So second medium is glass. So when it goes from one medium to another medium, this should be the actual path, correct? This should be the path of the incident ray. But when the light goes from one medium to another medium, there is a bending. So this new ray which is bent inwards, this is called as refracted ray. This is our incident ray and the refracted ray. There is an angle of incidence, there is angle of refraction. Clear? Hi Preetam, Ashad, Kiwi, cricket lovers, nice. Refractive index, yes. I'm going to explain the refractive index today in this class after, let's say, 20 minutes, not even 20 minutes, after, let's say, 10 to 15 minutes, okay? So just be patient, we are going to learn all this. Now, we have learnt laws of reflection. There were 2 laws of reflection. How many of you remember 2 laws of reflection? We have 2 more laws. These are for refraction. These are very similar to the earlier laws, just a little bit different. So let's understand. So the first law of refraction, which is similar to the second law of reflection. So what it says, the incident ray, there is an incident ray, sorry, this one is our incident ray, there is a refracted ray, and there is a normal. All 3 of them lie in the same plane. All 3 of them lie in the same plane. For example, if the incident ray is in this plane of this board, then the normal is also in the plane. So the refracted ray cannot come outside of the plane or cannot go inside. It has to be within this plane. So it has to be within this 2-dimensional region. This is the first law of refraction. And now the second law it is also called as Snell's law. तो 2 लॉज क्या है रिफ्रैक्शन के? पहला लॉ ये बताता है हमें, ये वाला, कि जो 3 रेज है, 2 रेज, इंसिडेंट रे, रिफ्रैक्टेड रे एंड द नॉर्मल, ये हमेशा एक प्लेन में रहेंगे, प्लेन के कभी बाहर नहीं आएगा कोई भी इनमें से, है ना? दैट इज द फर्स्ट लॉ. एंड हाउ इज द सेकेंड लॉ? सेकेंड लॉ ऑफ रिफ्रैक्शन, इसको ये भी बोलते हैं स्नेल्स लॉ, है ना? तो ये क्या बताता है हमें कि ये जो रेशियो है साइन ऑफ एंगल ऑफ इंसिडेंस टू द साइन ऑफ एंगल ऑफ रिफ्रैक्शन इज ऑलवेज कांस्टेंट. सो नाउ देयर इज अ साइन टर्म. डू यू नो व्हाट इज साइन? साइन, कॉस, यू मस्ट हैव लर्नड इन ट्रिग्नोमेट्री. आपने ट्रिग्नोमेट्री में पढ़ा होगा. अगर आपने नहीं पढ़ा तो मैं एक शॉर्टली बता देता हूं इसका मीनिंग क्या होता है. अगर कोई भी राइट एंगल ट्रायंगल है, देयर इज अ राइट एंगल ट्रायंगल, one of the angle is 90 degrees. Let's suppose this angle here is theta, है ना? This angle is theta. So I'll name this triangle as A, B and C. So sin theta कैसे define होता है? So sin theta is defined as ये जो opposite side है, which is AB divided by hypotenuse. So sin theta is nothing but AB divided by hypotenuse, which is AC. So opposite side divided by hypotenuse. This is how sin theta is defined. Okay. So now हम 2-3 एंगल्स के में मेजरमेंट और उसका साइन का वैल्यू बताता हूं आपको. So if the angle, so there is a angle measurements and there is a sin theta value. If the angle, if this angle theta is 0 degrees, angle is 0 degrees, then sin theta क्या होगा? Then sin theta will also be 0. If the angle is, let's suppose there is a first value, if the angle is 30 degrees, if the angle theta is 30 degree, then you can draw a triangle. So there is a very popular triangle you learn in your maths lectures in trigonometry. If this angle is 30, then this is 90 and this angle is 60. So when the angle is 30, the opposite side you call it as 1 and hypotenuse you call it as root just 2. Then this side you can use a Pythagoras theorem, and from the Pythagoras theorem it comes out to be root 3. Now sin 30 is 1 divided by 2, opposite side divided by hypotenuse. So sin of 30 is 1 by 2. Okay. How about sin 60? Let's write 45, 60 and 90. So when it is a sin 60, so now this is the angle 60, sin 60 is root 3 divided by 2. Sin of the 60 is root 3 divided by 2. How about 45? 45, you have another triangle here. So the two sides, these are equal. So these two angles, they are equal. This is 90. They both of them are 45 and 45. So this sides you call it as 1 and 1, just 1 unit. There is a 1 unit, this one is also 1 unit. So this will become root 2. So what is sine 45? 1 divided by root 2. Sine 45 is 1 divided by root 2. And what is sine 90? Just remember this, it is 1. Later in maths, you will get detailed analysis why they are only these values. You will learn in much detail in maths. Okay, right now just remember this. We will use it in our numericals. Alright, so now, okay, I'll rub this, or should I? Okay, I'll let it be as it is. Let's learn more about this. So what Snell's law says Snell, there is a name of a scientist, he said that whenever the light passes from one medium to another medium, there are these two angles. There is angle of incidence and angle of refraction. You take the sine of angle of incidence and sine of angle of refraction. So this ratio is always going to be constant. So this is our Snell's law. But here Snell gave one condition. What is that condition? This angle of incidence should be within this range. The minimum value is just above 0, because if it is 0, what will happen? If let's say angle of incidence is 0, so there is the angle of incidence which is 0 degrees. So what is happening now? Now the incident ray is along the normal. So in that case, it will just pass as it is. There is an angle of refraction also 0 degrees. Okay, so in this case we cannot use the Snell's law. Even when angle of incidence is 90, then what will happen? There is a angle of incidence. So angle this ray is coming very close to the boundary. So it may not go into the second medium. It will always go as it is. It will not enter. If there is some oscillation or some vibration, if the surface is not smooth, then only this ray will go inside the second medium. So that is the reason the angle of incidence is between 0 and 90. Clear? Rub it? Okay, I'll rub it. I'll just let it be. It's okay. So now let's understand the refractive index. Sometimes it is very easy to understand, and for some students it is very difficult. So those who have, like, once you understand it, you will be able to solve all kind of questions. And if you can't understand what is this refractive index, what is the meaning of it, it is very confusing for them. You can learn or rewatch the video multiple times, still you will have the questions or doubts. So pay attention, this is very important, the refractive index, and a lot of questions will come directly from this topic. So let's learn that. Now, what is the refractive index? Refractive index is defined as this equation. Refractive index, we use a letter N for the refractive index. It is defined as a ratio of C divided by V. So what is C? So speed of light is maximum in vacuum. This is called as C. This is the letter C. C will tell the speed of light in vacuum, which is 3 into 10 raised to 8 meters per second. And what is V? V is the speed of light in that medium. So C is speed of light in vacuum, and V is the speed of light in some medium, and N is the refractive index of that medium. Okay. Do the value of C can differ? Value of C is constant. This is always constant. Why? Because it is taken in vacuum. As long as it is vacuum, the value of C will not change. It does not change. It is a universal constant. But speed of light in different medium will change. So when the light goes from vacuum to let's suppose water or glass, then what will happen? The light will slow down. This speed is always less than c. So V is always less than c, and because of that the n, if you divide both sides by by V, so V divided by V less than c divided by V. So there is 1 is less than, what is c divided by V? It is the refractive index. So refractive index of a medium is always greater than 1. If the medium is vacuum, then the refractive index is 1. If the medium is vacuum, then it will be c divided by c. So refractive index is 1. So refractive index of vacuum is 1. For all the other medium which are transparent, light can pass through them, so the refractive index is always greater than 1. Okay. Now solve this question. What is the SI unit of refractive index? Can you tell me? What is the SI unit of refractive index? None. Nice. So what is refractive index? Refractive index is C divided by V. So what is the SI unit of refractive index? That should be equal to the SI unit of C divided by V. So what is the SI unit of C? C is the speed. So it is meter per second divided by V is again speed, which is meter per second. So this meter per second will get cancelled out. So C is just a number. It does not have any units. So it is none of the above. It is a ratio of two velocities. So that is the reason refractive index is just a number. It does not have any units, no units. Now solve this. Speed of light in a medium is this much. So what is the refractive index of that medium? Can you calculate? So speed of light in a medium, that means there is a V. V is given as 2 into 10 raised to 8 meters per second. And we want to calculate the refractive index, that is N. We want to calculate. So how will you calculate? 3 by 2, yes, that is correct. Nice. So N is nothing but C divided by V. But what is C? C value is 3 into 10 raised to 8 meters per second. That is speed of light in vacuum divided by this V, which is 2 10 raised to 8 meters per second. So you can cancel some of the terms. Cancel this meter per second, 10 raised to 8. You can cancel it out. So what is left? So now we can write N is equal to 3 by 2. That is the refractive index of the medium, which is option number B. Easy? Krishna, Aditya, Vinay, National Science Center, Aarti. Alright. So now let's combine. We have learned the second law of refraction, that was the Snell's law, and then we have learned the refractive index, the definition of refractive index. So let's just combine these two. Okay, so then we'll get the absolute refractive index. So what is absolute refractive index? It is the refractive index with respect to vacuum. So this means refractive index with respect to vacuum. So when you measure the refractive index with respect to vacuum, it is called as absolute refractive index. Okay. So it is defined as We know the refractive index is C divided by V, and the Snell's law said that when the light goes from one medium to another medium, this angle, sine of the angle of incidence to the sine of angle of refraction is constant. So people have done lot of experiment and they come to the conclusion that this ratio is nothing but the refractive index of the medium. So refractive index is nothing but sin I by sin R. So this is another way to calculate the refractive index. So here look carefully, one of the medium is vacuum. So if the first medium is vacuum, then we directly calculate the absolute refractive index. Okay, if one medium is vacuum, then we directly get the refractive index of the other medium. So this is the way to calculate the refractive index. This is the absolute refractive index. It is the refractive index with respect to vacuum. Clear? So now, how to find the relative refractive index? So what is the relative? Relative means with respect to something, right? So how do you find the relative refractive index? So here none of the two mediums are vacuum, both are other than vacuum. So this N1 and N2, they are the absolute refractive index of medium 1 and medium 2, right? So here how do you calculate the relative refractive index? Meaning of, किस चीज का मीनिंग चाहिए हिमांश? So relative means, so do you understand relative? Absolute is it does not change. Relative means if the first medium, अगर first medium हमने change कर दिया तो जो refractive index की value है it will keep on changing, right? So it will depend on what is this medium. If let's suppose there is a glass, or if this is a water, or if there is some other medium, so depending on यहाँ पे कौन सा मीडियम है, डिपेंडिंग ऑन दैट मीडियम, जो सेकेंड मीडियम है उसका रिफ्रैक्टिव इंडेक्स चेंज होगा. दैट इज द मीनिंग ऑफ रिलेटिव रिफ्रैक्टिव इंडेक्स. ओके, सो रिफ्रैक्टिव इंडेक्स ऑफ वन मीडियम with respect to the other medium is given by this equation. So how do you read this? So this is read as, so n21 means the refractive index of medium 2 with respect to medium 1. So it is the refractive index of the second medium with respect to the first medium, and this n21 you can write as n2 divided by n1. So what are these n2 and n1? These are the absolute values, absolute refractive index. Okay, sin, yes, this ratio sin I by sin R, it was given by our favorite scientist Snell. So Snell said this angle of incidence and this is the angle of refraction. So sin I by sin R is always going to be constant, correct? But this ratio will depend on what is the absolute refractive index of these two medium. So this ratio will be n2 by n1, and you can use this equation. ये ना बहुत easy equation है, how to remember the relative refractive index. तो अगर आपको कुछ remember करना है यहाँ पे, let's suppose there is a first medium, medium 1. There is an angle in the first medium which is our angle of incidence. ये n1 क्या है? Refractive index in the first medium. Now जैसे ही this ray goes to the other medium, there is medium 2, right? There is a medium 2, so there is an angle in the medium 2 and there is a refractive index in the medium 2. So how will you write this equation? When you start from medium 1, so जो पहला medium है उसका refractive index which is n1 multiplied by sine of the first angle which is in this case angle of incidence. This should be equal to N2, which is the refractive index of the next medium, multiplied by sine of the angle of refraction. So this is how you get the complete ratio. Now from here you can take the N1 and N2 in the same side, sine I and sine R. So divide this by sine R, you'll get sine I by sine R. This should be equal to N2 divided by N1. So N2 divided by N1. So this is our this ratio. And what is N2 by N1? ये अपना relative refractive index of the two combined mediums. Clear? हिंदी में बोलो. You got 99. Nice. हरिकृत. Great. So now एक और चीज है optical density. So optical density क्या होती है? So now यहां पे अगर एक रे, there is an incident ray, इस मीडियम से दूसरे मीडियम में जा रहा है, देन क्या होता है यहां पे, फ्रॉम वन मीडियम टू अनदर मीडियम, देन देयर इज अ बेंडिंग ऑफ लाइट. तो क्या होगा, इधर लाइट विल बेंड टूवर्ड्स और इट विल बेंड अवे फ्रॉम द नॉर्मल. ये हमारी नॉर्मल है, राइट? दिख रही है आपको नॉर्मल. सो व्हेन द लाइट गोज फ्रॉम मीडियम वन, व्हेन द लाइट गोज फ्रॉम मीडियम वन टू मीडियम टू, इन दिस केस ये क्या हो रहा है, light is bending towards the normal. So whenever light bend towards the normal, that is the optically denser. So there is a optically denser medium. और जब light पहला वाला जो मीडियम है, so with respect to this is the optically rarer medium. करेक्ट. सो जहां पे लाइट अंदर बेंड होती है वो ऑप्टिकली डेंसर है और पहला वाला ऑप्टिकली रेयर होगा. एंड एग्जैक्टली अपोजिट थिंग विल हैपन व्हेन द लाइट इज बेंडिंग अवे. सो यहां पे दिख रहा है नॉर्मल से लाइट क्या हो रही है, बेंडिंग अवे फ्रॉम द नॉर्मल. सो जब भी लाइट अवे फ्रॉम द नॉर्मल बेंड होती है, सो दिस वन इज गोइंग टू बी रेयर मीडियम and the first medium would be the denser medium. There is a denser medium. So this is not our density like mass divided by volume. ये वो वाला density नहीं है. There is a optical density. There is a optically denser. There is a optically rarer. मतलब जब लाइट उस मीडियम को देखती है, लाइट को क्या दिखता है यहां पे, बहुत रेयर मीडियम, मतलब बहुत जो उसके जो एटम्स है विथ रिस्पेक्ट टू द लाइट वो बहुत एक दूसरे के दूर दूर है, वो लाइट को ज्यादा बेंड नहीं करेंगे, ज्यादा डिस्टर्ब नहीं करेंगे. और ये जो ऑप्टिकली डेंसर है, तो इस वाले रीजन में जो भी एटम्स है, मॉलिक्यूल्स है, वो लाइट को बहुत ज्यादा बेंड करेंगे, बहुत ज्यादा डिस्टर्ब करेंगे, है ना. दैट इज द मीनिंग ऑफ ऑप्टिकल डेंसिटी. सो ऑप्टिकली डेंसर, सो हमें ये पता चल गया था N1 एंड N2 ये क्या है, रिफ्रैक्टिव इंडेक्स. There is the absolute refractive index of the rarer medium, absolute refractive index of the denser medium. तो हम refractive index को optical density के साथ कंपेयर कर सकते हैं. कैसे? जिसका refractive index कम है that is optically rarer, जिसका refractive index ज्यादा है it is optically denser. That's it. इतना सिंपल है. refractive index कम, optically rarer, रिफ्रैक्टिव इंडेक्स ज्यादा, ऑप्टिकली डेंसर. ठीक है. ओके, सो नाउ सॉल्व दिस क्वेश्चन. ओके, यहां पे क्या बोला है, द एब्सोल्यूट रिफ्रैक्टिव इंडेक्स ऑफ द मीडियम अदर देन वैक्यूम. मतलब वैक्यूम के अलावा अगर कोई हमारे पास मीडियम है तो उसका एब्सोल्यूट रिफ्रैक्टिव इंडेक्स, उसका वैल्यू क्या होगा, व्हाट इज द वैल्यू, ऑलवेज लेस देन 1 या फिर ग्रेटर देन 1, इक्वल टू 1 एंड 0. क्या होगा बताओ फटाफट. सो आपको याद है व्हाट इज ऑप्टिकल, सॉरी व्हाट इज द रिफ्रैक्टिव इंडेक्स? ऑप्शन ए. ओके, लेट्स फाइंड आउट. सो अगर देयर इज अ बाउंड्री, वन मीडियम इज वैक्यूम, ये अपना वैक्यूम मीडियम है, एंड अनदर मीडियम, ये कोई अलग मीडियम, लेट्स सपोज वाटर, कोई भी ट्रांसपेरेंट मीडियम, तो यहां पे क्या होगा? लाइट विल बेंड फ्रॉम वन मीडियम टू अनदर मीडियम. सो व्हेनेवर यू कंसीडर वन ऑफ द मीडियम एज वैक्यूम, तो हमें सीधा सीधा एब्सोल्यूट रिफ्रैक्टिव इंडेक्स की वैल्यू मिलेगी, है ना? तो रिफ्रैक्टिव इंडेक्स कैसे डिफाइन किया है? इस वाले मीडियम में लाइट का स्पीड है मान लो c, इस वाले मीडियम में वाटर में लाइट का स्पीड है v. सो द रिफ्रैक्टिव इंडेक्स ऑफ द वाटर इज गिवन एज c divided by v. Correct? c divided by this ratio is the absolute refractive index of the water. Water is other medium other than vacuum. So in that case इसका वैल्यू क्या होगा? Is it less than 1, greater than 1, equal to 1 and 0? आपको मैंने एकदम स्टार्टिंग में बोला था, ये जो c की वैल्यू है ना, ये कितना होता है? 3 into 10 raised to 8 meters per second. This is the maximum speed of light. लाइट का स्पीड इससे ज्यादा हो ही नहीं सकता. लाइट का क्या, किसी भी ऑब्जेक्ट का इससे ज्यादा स्पीड कभी हो ही नहीं सकता. There is a maximum speed of light in vacuum. So जब भी लाइट किसी दूसरे ट्रांसपेरेंट मीडियम में जाती है, it will have a lower speed. उसका स्पीड कम हो जाता है. तो उसका मतलब ये है v is less than c. अगर v is less than c, that means this ratio should be divide this by v both sides. So c divided by v less than v divided by v. So this is 1. 1 is less than n, or n is greater than 1. So जो absolute refractive index की वैल्यू है वो हमेशा greater than 1 होगा. Clear? Nice, Krishna and Ashu. You are wrong but understood. Correct. So there is a table of absolute refractive index. तो यहां पे आपको दिख रहा है अलग अलग, सॉरी, यहां पे आपको दिख रहा है अलग अलग मीडियम है. एयर के रिफ्रैक्टिव इंडेक्स क्या है? वैक्यूम से थोड़ी सी ज्यादा, जस्ट अबव. वैक्यूम की कितनी होती है? 1. इट इज एब्सोल्यूट 1. एयर की जस्ट लिटिल बिट ग्रेटर. देन देयर आर अदर मटेरियल्स लाइक वाटर, वी जनरली यूज 1.33. देन ग्लास typically we use as 1.5 और 1.6 डिपेंडिंग ऑन कि कौन से टाइप की, कौन सा मटेरियल है. देन द मैक्सिमम रिफ्रैक्टिव इंडेक्स इज डायमंड विच इज 2.4. सो अभी तक जितने भी मटेरियल्स डिस्कवर्ड हुए, मतलब लोगों ने डिस्कवर किए हैं, उसमें डायमंड का जो रिफ्रैक्टिव इंडेक्स है सबसे ज्यादा है 2.4. एंड इसी वजह से जो डायमंड का जो ब्रिलियंस है, डायमंड तक चमकता क्यों है? बिकॉज ऑफ द वेरी हाई रिफ्रैक्टिव इंडेक्स. सो लाइट का स्पीड सबसे ज्यादा कहां पे होगा? सबसे ज्यादा होगा वैक्यूम में, उसके बाद एयर में, उसके बाद जैसे ही रिफ्रैक्टिव इंडेक्स बढ़ेगा लाइट का स्पीड कम होता जाएगा, एंड फाइनली डायमंड में लाइट का स्पीड इज द लोवेस्ट इन डायमंड. क्लियर? और अगर इस टेबल से आपको ऑप्टिकल डेंसिटी के बारे में बताना है, तो ऑप्टिकल डेंसिटी इसका क्या होगा? लोवेस्ट ऑप्टिकल डेंसिटी ऑफ वैक्यूम एंड एयर. सबसे कम ऑप्टिकल डेंसिटी. जैसे जैसे रिफ्रैक्टिव इंडेक्स बढ़ेगा, जैसे जैसे आपको रिफ्रैक्टिव इंडेक्स बढ़ता हुआ दिख रहा है, देन व्हाट विल हैपन? दीज आर बिकमिंग डेंसर, ऑप्टिकली डेंसर. सो दे विल रेजिस्ट द फ्लो ऑफ लाइट. लाइट को रेजिस्ट करेंगे, इसी वजह से लाइट का स्पीड क्या होगा? कम होगा. सो ऑप्टिकल डेंसिटी ऑफ द डायमंड विल बी द मैक्सिमम. डायमंड की ऑप्टिकल डेंसिटी क्या होगी? हमेशा इट वुड बी मैक्सिमम. क्लियर? इजी है, राइट? नाउ सॉल्व दिस क्वेश्चन. So which of the following is true? N1, N2 are the absolute refractive index. So there is N1, there is N2. N1 and N2. ये हमें ना दो मेथड से सॉल्व करेंगे. एक तो सीधा सीधा जस्ट यूजिंग द एब्सोल्यूट ऑप्टिकल डेंसिटी वाला चीज, C and B. Okay, somebody is saying C, somebody is saying B. All right, B. All right, most of you are saying B. Great. So let's find out. C तो नहीं होगा. क्यों बता रहा हूं मैं आपको? C कब होगा? C कब होगा? C का क्या मीनिंग है? दोनों का रिफ्रैक्टिव इंडेक्स इक्वल है. अगर दोनों का रिफ्रैक्टिव इंडेक्स इक्वल होगा तो लाइट विल पास एज इट इज. लाइट कभी बेंड होगी नहीं, है ना. अगर दोनों चीज का, दोनों जो मीडियम है उनका रिफ्रैक्टिव इंडेक्स सेम होगा तो लाइट बेंड होगा ही नहीं. बट यहां पे आपको साफ दिख रहा है लाइट इज बेंडिंग, तो C तो ऑब्वियसली नहीं होगा, है ना. नाउ अब देयर इज अ इंसिडेंट रे. फॉर एग्जांपल दिस इज द पाथ ऑफ द इंसिडेंट रे. ये अपना क्या है? इंसिडेंट रे. ये डॉटेड लाइन जो दिख रही है आपको ब्लू कलर की, दैट इज अ नॉर्मल. सो व्हाट हैपेंस? The light is bending away. Light is bending away from the normal. So जब भी light away from the normal bend होगी, इसका क्या मतलब है? इसका मतलब ये है N2 is a rarer medium. So this one is a rarer and this one is a optically denser. So N1 is optically denser, meaning N1 का जो वैल्यू है, जो रिफ्रैक्टिव इंडेक्स इज ग्रेटर देन N2. सो वैल्यू ऑफ N1 इज ग्रेटर देन N2. सो दैट इज द राइट ऑप्शन. समझ में आ रहा है अभी? इट इज नॉट ऑप्शन नंबर बी, इट इज करेक्ट ऑप्शन इज ऑप्शन नंबर ए. अभी हमें ना इस चीज को दूसरे तरीके से स्नेल्स लॉ का यूज करके सॉल्व करेंगे. कैसे करेंगे? तो यहां पे आपको स्नेल्स लॉ पता है? स्नेल्स लॉ क्या बोलता है? फ्रॉम द फर्स्ट मीडियम इसका रिफ्रैक्टिव इंडेक्स इज N1. सो आई विल राइट N1 साइन ऑफ एंगल I, साइन ऑफ एंगल I, दिस शुड बी इक्वल टू द, इन द सेकेंड मीडियम, जैसे लाइट सेकेंड मीडियम में जाएगी इट इज N2 साइन ऑफ एंगल R. ठीक है. तो अभी जो N1 टर्म है वो एक साइड में लेते हैं और साइन की टर्म से वो दूसरे साइड में लेते हैं. तो N1 डिवाइडेड बाय N2 इज इक्वल टू साइन R डिवाइडेड बाय साइन I. तो यहां पे क्या दिख रहा है? यहां पे लिखा हुआ है R इज ग्रेटर देन I. तो एंगल ऑफ रिफ्रैक्शन इज ग्रेटर देन एंगल ऑफ इंसिडेंस. यहां पे भी दिख रहा है ना आपको? एंगल ऑफ रिफ्रैक्शन इज ग्रेटर देन एंगल ऑफ इंसिडेंस. तो उसका मीनिंग क्या होगा? अगर एंगल बढ़ाओगे आप तो साइन के वैल्यूज क्या होगा? व्हेन यू इंक्रीज द एंगल, मैंने एक चार्ट बताया था ना, जैसे ही एंगल की वैल्यूज बढ़ती है साइन की वैल्यूज भी बढ़ेगी फ्रॉम 0 to 90, है ना. तो जैसे ही एंगल अगर बढ़ेगा तो इफ R इज ग्रेटर देन I, तो साइन R इज ग्रेटर देन साइन I, है ना. अगर एंगल की वैल्यू बढ़ेगी तो साइन की भी वैल्यूज बढ़ जाएगी. तो अभी हमें ये रेशियो चाहिए, साइन R बाय साइन I. सो डिवाइड बोथ साइड्स बाय साइन I. सो साइन R डिवाइडेड बाय साइन I, ये क्या आएगा? इट इज ग्रेटर देन 1. So this side is greater than 1. This side is greater than 1. But what is this? Sin R by sin I? It is N1 by N2. So we can substitute. So यहां से ये जो रेशियो है sin R by sin I, इसको N1 by N2 में सब्स्टिट्यूट करता हूं. So N1 divided by N2 is greater than 1. So that means N1 is greater than N2, है ना. अगेन हमें क्या मिला? ऑप्शन नंबर ए. सो इधर आप ऑप्टिकल डेंसिटी से भी पता कर सकते हो या फिर द बेस्ट वे इज टू यूज स्नेल्स लॉ. दिस इक्वेशन विच इज द Snell's law. You can use a Snell's law to get the 100% accurate answer. Optical density से कभी कभी गलती हो सकती है, ठीक है? Now this is your homework. I'll explain. There's a homework. You can solve and type your answers in the chat so that we can take this question in the next class. So I'll explain question. So ray of light travel from medium A. तो यहाँ पे medium A है. It is traveling from A to medium B, है ना? Traveling from medium A to medium B. So there is an incident ray, and this is the refracted ray. So the refractive index of medium B relative to medium A, ये चीज हमें फाइंड करनी है. Refractive index of medium B relative to medium A, ये हमें फाइंड करनी है, and it would be one of this. So यहाँ पे दो तीन चीजें आपको पता होनी चाहिए. एक तो जो रिलेटिव रिफ्रैक्टिव इंडेक्स है वो कैसे डिफाइन किया है. सो गेट दैट इक्वेशन फॉर द रिलेटिव रिफ्रैक्टिव इंडेक्स. देन यू नीड, यहां पे अलग अलग एंगल दिख रहे हैं, ठीक है, लॉट ऑफ डिफरेंट एंगल्स. सो इसमें से आपको ये पता करना है विच इज अवर एंगल ऑफ इंसिडेंस, विच इज द एंगल ऑफ रिफ्रैक्शन, एंड फ्रॉम दैट you need to find out values of sine of that angle, and once you do that you can solve this question and answer would be one of this option, correct? So do solve it and type your answer in the chat. We'll solve the exact question in the next class, and yeah, we'll continue. So that's it for today. Thank you so much everyone. Bye bye, take care, have fun, see you again next class. Probably next week, either Monday or Tuesday. Subscribe to the channel so that you will get to know when is the next class. Bye bye everyone, enjoy.